Okay, so welcome everyone. We are here to learn a little bit about logarithmic differentiation here today. So in the past, we have learned how to take derivatives in general using a multitude of rules. And then we learned about how to take derivatives of logarithms in particular in this section. So now we're going to piece it together to take the derivative of fancier looking functions using this technique called logarithmic differentiation. Five-step process that is outlined in our textbook. The first step is to apply the logarithm, the natural logarithm, to both sides. So after we apply the natural logarithm to both sides, we're going to use properties of logarithms to expand the right side as much as possible, the right-hand side. Third, we're going to then take the derivative of both sides, and notice that on the left, we're going to have this guy always, always, always on the left when we take the derivative implicitly. And then fourth, we'll solve for dy dx. How? By multiplying both sides by y. And then last, we're going to replace y with whatever the function h of x is. So that's a plan. So let's get to it. First, though, we're going to review the properties of logarithms that you're going to have to get very comfortable using. The first one is that the log of a product can be separated into a sum of the two logs. So notice how I take the x times y and I can split it up into a sum. The log of a quotient can be split up into a subtraction problem, a difference. So the quotient goes into a subtraction. X goes first, y goes second. Third, the log of something to a power means that the power can get brought down and it becomes the coefficient. Those are the three properties that we are going to use in that order. In fact, we're going to use them in that order. Other things to remember is that the log base b of 1 is 0 and that the log base b of b is 1. How does that translate into the natural log world? That means that the natural log, which happens to be base e of e, since the base matches the of e part, is also equal to 1. So you've got to remember that the natural log of e, and this is of e because the natural log has a base of e, is equal to 1. Okay, so what else did I need you to remember? I think that's it for now. Let's go ahead then and jump in. So here's the first function that we want to take the derivative of. Step 1 is to apply the logarithm on both sides. So I'm going to apply a natural log on both sides. So this is the natural log of y on the left equals to the natural log of all of that stuff on the right. By the way, I'm going to keep in mind this is the answer here. I'm going to keep that in mind. Keep that in the back of my mind there as I work through this. And what I have inside here is a big giant fraction. And I have an x to the fourth times a fourth root. A fourth root of something can be written as a 1/4 power. I like powers because then I can use the power rule, remember? So we want to keep those powers, those roots written as powers. And this is a 4 minus 6x to the fourth. And then on the bottom, I have an e to the negative 5x. And I have a parentheses, negative 3x minus 5. Okay, now remember that step 2 is to expand as much as possible using these rules. So let me translate to you what the rules meant for logarithms. This rule here, and we're going to go in order. So rule 1 and rule 2. So rule 1 says anything that's in the numerator, so this is for numerators, anything that's in numerators gets split up as sums. Anything in the denominator, this says that anything in the denominator gets subtracted. So denominators are subtracted. That's how this translates into my mind. That's what I'm thinking, and that's what I want you to think. I want you to think numerators that are being multiplied, numerators that are being multiplied, turn it into addition. Denominators, those are going to be subtracted. So if you take a look at the pattern here, the y is on the bottom, and that's why we're subtracting the log base b of y. So denominators are subtracted. Okay, numerators, we're going to separate the product into a sum. Okay, so now let's take that and apply it to this problem. Numerators, we're going to separate the products into a sum. Denominators, they're going to get subtracted. So the denominators are both of these guys here. So that means, and I said both because I do see two guys. When I put a multiplication symbol there, there's 1, 2 factors. So those two guys are going to be subtracted once I apply that logarithm property to it. And then up on top, again, I have 1, 2 guys. This is a bigger guy over here. Those two guys are going to be added because they are in the numerator. So let's split that up then. Split it up. On the left, I have the natural log of y still, and on the right, remember, the log says to apply it on everything using those properties. So now I have a natural log of x to the 4th plus, because that's a numerator, a natural log of 4 minus 6x to the 4th, all raised to the 1/4 power. Those were in the numerator, and that's why those are being added. And then I have the denominator, so it's going to be minus the natural log of e to the negative 5x, minus one more time, because it's also in the denominator, the natural log of negative 3x minus 5. So that's how I expand that using the properties of products and quotients. Okay, so that was the first two properties of products and quotients. Now I'm going to use the power property that says take the power and put it down in front. So we're going to take the power and put it down as a coefficient. Okay, so powers get brought down to become coefficients. Left side is still the natural log of y. This power is going to become a coefficient. Ooh, I don't like that color. Let me change that to a yellow now. So this power is going to become a coefficient. This power is going to become a coefficient. This power is going to become a coefficient. Okay, so all of this parenthesis is a little bit too short there. All of those powers are going to become coefficients. So that's a 4 times the natural log of x plus a 1/4 times the natural log of 4 minus 6x to the 4th. And then negative times a negative is a plus 5x times the natural log of e. Ooh, anybody remember what that is? Natural log of e, we know what that is. Minus the natural log of negative 3x minus 5. The natural log of e, remember the base here match. The bases match, so that's just equal to 1. When the bases match, that just equals to 1. Right there. So what we've got going on here, this natural log of e, is really just a times 1. This is 5x times 1. So what I'm going to do is clean it up one more time before I take my derivative, before I move on to the next step. I have the natural log of y equals to 4 times the natural log of x plus 1/4 times the natural log of 4 minus 6x to the 4th plus 5x times 1 minus the natural log of a negative 3x minus 5. Okay, that's all part of step 2. I'm referring you back here where it says expand as much as possible and clean it up, basically. So we cleaned it up. We cleaned it up using these properties here of logarithms. So now let's differentiate both sides right here. Differentiate both sides with respect to x. Notice that on the left, we're going to have a 1 over y times dy dx. Why? Why? What do we mean by that? Well, because this is the natural log of y, and we learned last time that the derivative of the natural log of something, of anything, is 1 over that something times the derivative. So this is just going to be, like it says over there, the derivative of all of this. So let me change colors now since I'm taking the derivative. Derivative on both sides. So we're taking the derivative on both sides now. And the derivative rule says 1 over the stuff inside times the derivative of that stuff inside. So 1 over y times dy dx equals, same thing here. I have a 4 times 1 over x times the derivative of x, which is 1, plus 1/4. I'm just bringing my coefficient down, times the derivative of ln of that stuff is, again, 1 over that stuff, so 1 over 4 minus 6x to the 4th, times the derivative of that stuff inside. So the derivative of that stuff inside is actually going to be a little bit more interesting than the previous one. The derivative of this stuff inside is going to be a negative 24x to the 3rd. Right? And notice I'm putting it on top on purpose because that's over 1. That's not going to go in the denominator. It's the fraction times that, not the denominator times that. So the fraction means it's over 1. That's negative 24x to the 3rd. So that was the derivative of this one. Moving on to this one. The derivative of 5x is just a 5. And then minus the derivative of the last term is going to be 1 over the stuff times the derivative of the stuff. Okay, so 1 over the stuff, negative 3x minus 5, times the derivative of the stuff. And again, it's in the numerator. So that's a negative 3 over 1. It's in the numerator. Derivative is done. Derivative is done. Now, I'm pretty sure the next step is just to simplify. We're going to need to simplify and multiply both sides by y because we want to solve for dy dx. So why am I multiplying by y? Well, because there is a y in the denominator here, and I want to get this guy alone here. So I'm going to multiply everything on the left and everything on the right by a y. So if I put, I'm going to put, I'll use brackets. So everything on the right side, which needs to be cleaned up, I'm going to multiply it, and I'll use green for what I'm multiplying by. I'm going to multiply it by y there, and I'm going to multiply it by y here, right? Why am I multiplying by y? And here's my equal sign, remember, on both sides. I'm multiplying by y so that these can cancel. And so now I get my dy dx is equal to this y that I just multiplied by on both sides times, all that beautiful stuff that we need to clean up. So let's clean it up. 4 times 1 over x, that's just 4 over x, plus, so this is 1/4 times all of that. So let's just put all the numerators together and all the denominators together. And so since, I'm going to erase that plus sign because since this is a minus sign here, that means that it's going to multiply together to give me a negative. So this is a negative. On top, I have a 24x to the 3rd. On bottom, I have a 4 times a 4 minus 6x to the 4th. Okay, there's that second fraction. Plus 5, that's still a lonely little 5, minus, actually that's going to turn into a plus because when I multiply this on top by that, negative times negative is a positive 3 over that denominator of negative 3x minus 5. Okay, one more thing that can simplify here is this 4 can go into that 24 6 times. And now what's left is to replace this y. In the very last step, we have to replace that y with the original definition of y. What was y to begin with? Well, to begin with, y was equal to all of this right here. See, it says y equals to all of that. So I need to copy all of that and put it down there. Again, x to the 4th times the 4th root of 4 minus 6x to the 4th in front of those big brackets. So dy dx is, I'm going to go back now, leave it as red. Here's what y is. It's going to be x to the fourth times the fourth root of, and I already forgot, so I'm going to back it up, 4 minus 6x to the fourth, 4 minus 6x to the fourth, all over. And the bottom is e to the negative 5x, e to the negative 5x times parentheses, I have to keep going back, negative 3x minus 5. Negative 3x minus 5. Negative 3x minus 5. That's y. Okay, that stuff right there is my y. I'm going to shade it in yellow so that you can see that that's what that is. That's y right there. And now I have to put times. All of that is being multiplied by my blue stuff in the brackets. So I got to write it down here in the brackets. And so that I can see it better, I'm going to scroll down a little bit. So this is 4 over x minus 6x to the third over 4 minus 6x to the fourth, parentheses, plus a lonely 5, plus 3 over the parentheses of negative 3x minus 5. The end. That is dy dx right there. So what did we do? We took the logarithm of both sides. Let me box this up. We took the logarithm of both sides in step 1. Let me show you where I did that. Took the logarithm of both sides. Step 2, expand as much as possible using those properties of logs. As much as possible. It took me 3 steps to expand as much as possible. Then, once you've expanded, take the derivative on both sides using those new rules. 1 over y, dy dx. Simplify. And then finally, we multiplied by y on both sides so that it would solve for dy dx. And that is how we use logarithms to complete logarithmic differentiation. Awesome. I'll see you next time for more examples.